Okay, we're doing an experiment in kinetics, and we have 3 sets of data, 3 experiments that allow us to determine the order of the reaction. The reaction is the between carbon monoxide gas and chlorine gas to make COCl2. The 3 experiments are set up so that we can control to see what the effect of each concentration of reagent is. So in the case of experiment 1 and 2, the chlorine gas concentration is kept constant, but the carbon monoxide concentration is varied, and we see what effect it has on the rate. We see that doubling the carbon monoxide concentration has doubled the rate, and that would indicate that it's first order with respect to carbon monoxide. So for experiment 1 and 2, we revealed that a doubling of carbon monoxide causes a doubling of the reaction rate. Chlorine gas is kept constant on these 2 trials, so any rate increase is solely attributable to the carbon monoxide concentration. The reaction is first order in carbon monoxide. In the second comparison, we're looking at 1 and 3. In 1 and 3, the carbon monoxide concentration is kept constant instead, and we've doubled the chlorine concentration. And we've noticed that it quadruples the rate. So when you double the concentration of a chemical and it causes a quadrupling of the rate, then we can attribute that it's second order. So the overall rate law is rate is equal to the rate constant times the concentration of carbon monoxide times the concentration of chlorine gas to the power of 2. Now if you want to find out what the value of the rate constant K is, we can transpose these 2 things, put R over those 2 quantities, which is what we've done here. And then we pick one data set. We'll take the results from experiment 1, and we'll plug in all the numbers. Don't forget to square the value of 0.2, because it's the rate law says that it's squared, gives the correct rate. And when you square the numbers, you also square the units. So moles per liter becomes molarity squared. So it's moles squared per liter squared. We cancel out moles per liter here and there, and it leaves us with per second and molarity squared. It looks like this if you write it in the base units, but I simplified it writing molarity to the -2, seconds to the -1. And we're only allowed 2 significant figures in this data, so the final answer is 25, molarity is to the -2, seconds to the -1.